Dokie. So, 2C question 7. Now, I've decided to skip question 6 because you've got this nice example here. So look at example 10, then that should help you do question 6. So I thought I'll do 7 and 8 for something that's a little bit different. All right. It says the roots of equation x squared minus 6x plus 7 equals 0 are alpha and beta. So let's write that down. Using our product and sum, we can see that so our sum of alpha plus beta is minus b on a, and that equals minus 6 on a is 1, so it's 6. So the if the b is minus 6, minus b is positive 6, right? So really what we're getting out of that is the idea that an alpha plus a beta equals a 6. That's coming from the sum of roots. Now if I think about the product of roots, that equals c on a. Right, from here it would be 7 on 1. 7, right? So I'm going to write this. If root 1 is alpha and root 2 is beta, and we do a product, we would get 7. Okay. Alrighty. Now, they say we want to now create an entirely new quadratic. So find a new quadratic equation with roots alpha plus 1 on beta and beta plus 1 on alpha. So what is it? Alpha plus 1 on beta, beta plus 1 on alpha. Right? So roots alpha plus 1 on beta and beta plus 1 on alpha. Okay, so what would the sum look like? Sum of roots would be alpha plus beta, alpha plus beta, plus, let's do the 1 on alpha first, and the 1 on beta. Okay, now I know what that equals. That equals a 6, right? So if we thought about that as a 6, this I'm not so sure yet, so let's have a look. Alpha plus beta plus, now let's think about a common denominator. Alpha, beta, right? This is like if I had a half plus a third. How would I make a common denominator? I'd do 2 times 3 is 6. So alpha times beta gives the common denominator. Now here, if I've multiplied by beta, I'll have to multiply the top by beta. Here I've multiplied by alpha, so to get the common denominator, so I times the top. So what we end up with is the sum being 6, right? So that bit there was 6. Alpha beta is 7. So that's here is 7. And another alpha plus beta, beta plus alpha, same thing. Right? So it's 6 plus 6 sevenths. Or if you like, you could say an improper fraction there. 6 sevens are 42. 42 plus 6, 48. 48 sevenths, if you like. Or 6 and 6 sevenths. That's the sum. Now recall that sums of roots are minus b on a. So what I'm thinking at the moment is that the a term is most likely a 7, right? And the b term is most likely a minus 48, right? But we're going to need to do the C on A. We need the C term anyway, and then we can confirm if that's the case or not. So if we looked at the product of alpha plus 1 on beta, we want the product with beta plus 1 on alpha. Okay, so I'm just going to do FOIL. We get alpha beta plus alpha times 1 on alpha. That's going to be alpha on alpha. That's 1. 1 on beta times beta. That will be beta on beta. That's 1. And then the outside here would be 1 on alpha beta. So I know that alpha beta is 7, right? So I'm going to get 7 plus 1, that's 9, plus 1 on 7. Okay, so that is 64 on 7. And good, the A terms are matching up there. So let me write this in black. That's C on A. So therefore, the C term I've got there is a 64. Right. So if I put this all together in a quadratic, I could say therefore a quadratic would be 7x squared minus 48x, right? So we're just using this idea the quadratic can be written like this. Okay, we're talking about sum and product of roots, hence this is going to be equal to 0. The C term is a plus 64, and don't forget the equals to 0. Okay. Actually, let me just check, is there anything else that was needed in that question before I sign off the video? So it says find a quadratic. Yep, we did it. All right, good.